What happens to the water you drink before bedtime? While you sleep, your kidneys, blood, brain, and cells are still carefully managing every drop. Water doesn't simply sit inside your stomach overnight. It quickly becomes part of a constantly moving system that connects your digestive tract, bloodstream, kidneys, and cells. After you swallow water, it passes through the esophagus and reaches the stomach, where it begins moving onward rather than being stored for the night. Because water requires little digestion, it can move through the stomach and small intestine relatively quickly, depending on what else you consumed with it. Inside the small intestine, water crosses the intestinal lining and enters the fluid surrounding your blood vessels before becoming part of circulation. Now the water is no longer simply something you drank. It has become part of the body's internal fluid environment. This matters at night because your body never truly switches off. Even during deep sleep, cells continue producing energy and generating waste. And this is where your kidneys become especially important. They continuously monitor the composition of your blood and adjust how much water your body keeps. Each kidney contains roughly 1 million tiny filtering units called nephrons, working together to process enormous amounts of fluid every day. A nephron begins filtration at a microscopic structure called the glomerulus, where pressure pushes water and small dissolved substances out of the blood. But your kidneys don't simply throw that filtered fluid away. They carefully reclaim substances your body still needs. This recycling process is one reason your kidneys are so efficient. They can filter a huge volume while returning most of the valuable water back to circulation. At night, a hormone called antidiuretic hormone, or ADH, becomes particularly important in controlling how much water your kidneys conserve. ADH tells kidney tubules to become more permeable to water, allowing more water to return to the bloodstream, instead of leaving as urine. This is one reason healthy people often produce more concentrated urine during the night than they would after drinking large amounts of fluid during the day. Your kidneys are also watching electrolytes such as sodium and potassium, because water balance and electrolyte balance are closely connected. If the concentration of dissolved particles in your blood changes, specialized sensors help your brain detect that shift and coordinate the body's response. These sensors are called osmoreceptors. They help detect changes in the concentration of body fluids and influence thirst and hormone release. So even while you're unconscious during sleep, your brain and kidneys are communicating through hormones and feedback signals. This is called homeostasis, the body's remarkable ability to keep its internal environment within a safe operating range. Water contributes to this balance by helping regulate blood volume, transport substances, lubricate tissues, and support countless chemical reactions. Inside cells, water provides the environment, where many biochemical reactions can occur, from energy production to the movement of molecules. Your brain also depends heavily on carefully controlled body fluids, because nerve cells require precise chemical conditions to communicate properly. However, more water is not automatically better. The body needs the right amount, at the right time, with the right electrolyte balance. Drinking an unusually large amount of water in a short period can overwhelm the body's ability to remove excess water quickly. When excess water dilutes the sodium concentration in body fluids too much, the balance between water and electrolytes can become disturbed. This is why hydration is better understood as balance, rather than simply trying to drink as much water as possible. There is another nighttime factor. Your body naturally changes hormone levels and kidney activity as part of the sleep-wake cycle. Your circadian system helps coordinate these changes, linking daily rhythms with hormone release, temperature regulation, metabolism, and fluid handling. During normal sleep, ADH levels generally support greater water conservation, helping reduce urine production and protect uninterrupted rest. But the bladder keeps collecting urine because the kidneys never completely stop filtering urine in your blood. As the bladder gradually fills, stretch receptors in its wall detect the increasing volume. Those signals travel toward the nervous system, contributing to the sensation that eventually tells you it's time to urinate. This explains why drinking a large amount immediately before sleep may increase the chance of waking during the night to use the bathroom. Frequent nighttime urination, however, isn't always about drinking water before bed. Many different body processes can influence urine production. For example, changes in blood pressure, hormones, kidney function, medications, and other conditions can affect how much urine is produced. The cardiovascular system also benefits from proper fluid balance because blood volume influences how efficiently the heart and vessels circulate blood. Blood volume must remain within a functional range. Too little circulating fluid can challenge circulation, while excessive fluid can also place stress on the system. Water also participates in temperature regulation. Even while sleeping, your body continuously produces heat through metabolism. Water also participates in temperature regulation. Even while sleeping, your body continuously produces heat through metabolism. Your body uses several mechanisms to control temperature, including blood flow changes and evaporation from the skin. Water is also essential for saliva, mucus, joint fluid, and other specialized body fluids that protect and support tissues. Inside joints, synovial fluid helps reduce friction between moving surfaces, allowing bones to move smoothly against one another. In the digestive tract, water also helps maintain the fluid content of intestinal material, supporting normal movement through the bowel. This means hydration affects far more than thirst. It influences circulation, filtration, cellular chemistry, temperature control, and waste removal. Yet your body is remarkably good at detecting when fluid balance starts changing. Thirst is one of those signals. When the brain detects increased fluid concentration or reduced available water, thirst can become stronger. The kidneys provide another response by adjusting how much water is returned to the blood and how much is removed through urine. Think of the kidneys as precision recycling centers. They constantly decide what the body should keep and what it can safely eliminate. And that recycling happens while you're asleep, without you consciously controlling each microscopic decision.
So what should you remember about nighttime hydration? The goal isn't to flood your body with water before bed.
Instead, hydration is about maintaining a healthy fluid balance throughout the day, allowing your body systems to regulate themselves naturally.
Your kidneys, brain, hormones, blood vessels, bladder, and cells are constantly cooperating to achieve that balance. Every glass of water becomes part of this remarkable network of filtration, transport, chemical reactions, and cellular life. And the fascinating part is that most of this work happens silently, without you ever feeling the individual processes taking place. While your conscious mind rests, your kidneys are filtering, your heart is circulating, your cells are producing energy, and your hormones are regulating balance. That is the hidden physiology of nighttime hydration. Not simply drinking water, but maintaining the internal environment that keeps your organs functioning. So tonight, remember that your body doesn't go offline when you fall asleep. Its maintenance systems continue working around the clock. The real secret of hydration is balance. Enough fluid to support your cells and organs, without forcing your body to handle more than it needs.
Your body is working every second, even while you sleep. Follow Core Anatomy for more fascinating journeys inside the human body.
Thanks for watching. Like, share, and comment if you learned something new. And if you watched till the end, look out for our full-length video for even more fascinating human anatomy. Subscribe for more.